Started. Hello everyone. Today we will be solving problem C for today's Codeforces round, where you are given a tree with n vertices and you are also given two special vertices, start and end. Okay. Now you have a mouse which is starting on the start index and you have to give that mouse some directions by printing a permutation, and you want that at the end of all the steps the mouse should reach exactly the end node. Okay, so first of all, an answer always exists, so we don't have to think of this -1 condition. Okay, I'll explain why. First, how are the operations happening? Let's say the mouse is at some vertex u and the next item in the permutation is P of I. So the mouse will move one node closer to the vertex in the permutation. Okay. Now we'll understand the question using the biggest test case over here. First of all, 1 to 2, 1 to 3, 1 to 4, then you have 4 to 5 and 5 to 6. Okay. This is your start node and this is your end node. Okay, the answer given is 143265. First, the mouse is starting over here. Now the permutation starts from 1, so it stays over here. Now the next value is 4, so it will move to 4. The next value is 3. So if I have to go from 4 to 3, I will have to go here, right? So now the mouse is back on 1. Now 2 is next, so I will move to 2. If I have to go to 6, from 2 I will have to come back at 1. And the last is 5, which means I will come back to 4. So 1 was my start node, 4th is my end node, and I have successfully made the mouse go from start to end. Now we want a permutation such that it will work in all possible test cases. Okay, we are not looking for any corner cases. We will consider all test cases at once. Now, one easy method which you might have thought is that, let's say we want to go from 1 to 3. Okay, and we have some subtree over here, let's say 4 and 5, and some over here. Now if this is balanced, then you can perform one here, again back. So if the subtrees are balanced, then you can easily go and come back to your start node. And this is how you might use all the extra nodes without moving anywhere. And you will be still on node number 1. After that, I can just go to 2 and go to 3, and that would be my answer. But the issue comes, what if my subtrees are not balanced? Let's say there are 4 nodes over here and only 2 over here. Then it is very difficult to balance both of these, since now there are 4 over here and 2 over here. If the difference was 1, then maybe you could have tried first this, then this, then this, then this, and then this. But the difference is more than 1, and this can happen in many cases. So we would not try this. Now let's try to go on our original approach. Let's say we are on 1 and we have to go somewhere, x. Okay, now I have some extra nodes over here, 2, 3, 4, many extra nodes. Now my start node is 1, end node is x. So 1 and x can easily be my answer, but I still have to accommodate these other nodes. How shall I do this such that I don't go anywhere away from X. So for this, let's try something known as reverse DFS. What is reverse DFS? Now see, you are starting from 1. You have to accommodate all these extra nodes which are not in your path. So let's take a reverse DFS. How would a reverse DFS come? 1, 2, 3, 4. Simple, right? Because you start from 1, 1 to 2, 2 to 3, 3 to 4. Right? Now let's reverse this. It will become 4, 3, 2, 1. Now let's try this on this tree. You start from 1, next is 4 in the permutation. So you go to 2. Next is 3. So you come to 3. Next is 2. So you come back to 2. And 1. So you come back to 1. So as you can see, we have went and we came back to 1 by performing this reverse DFS. Let's try on a very skewed tree so you would get an understanding of this is actually working. Let's say something very big, 2, 3, 4, 5. Okay, and here it is 6, 7. Okay, completely skewed tree. Let's put one more here, 8. Okay, and this is your target node. So 1 and X would easily be your answer, but now you need to accommodate the other nodes. So we are at 1 now. Let's take DFS of all the other nodes. Okay, 1. So it is 1, 2, 3, 4, 8, 5. We will not take X because X we will go later. We will take DFS of all the parts but not X. After this 6 and 7. Now reverse this. 7, 6, 5, 8, 4, 3, 2, 1. Okay. Now if you are starting at 1, you start at 1. 7 is the first value, you come to 6. 6 is second value, so you don't do anything. Now third value is 5, so you come back to 1. Fourth value is 8, so you go down to 2. Fifth value is 4, go down to 3. Sixth value is 3, stay over there. Next value is 2, come back to 2. Next value is 1, come back to 1. So you can clearly see by reverse DFSing the other nodes which are not important. You can go and come back on the same node, and this will make our problem very easy. Let's see how I have implemented this code. Okay. First of all, I have a basic DFS just to pre-compute the parents of each node. Okay, I am always taking my start node as my root. Okay, once I am pre-computing the basic DFS, I am finding a path from A to B, because from A to B that is my most easiest answer, right? Now I am creating a path from A to B. This is also standard trees. Okay. Now let's solve the problem. Okay. So what this find function is what this find function is doing is that, let's say we have a node 1 and we have to go to another node 2. So it will find the DFS of all the other nodes attached to 1. Attached to 1, not attached to 2. Okay. So this IDX is the current index of where we are currently in our path. Okay. This vector will store the current DFS from that node. Okay. So for all nodes ahead, which is not my next node in the path from start to end. Okay. So we are calculating the extra nodes, which we just have to accommodate. So all the extra nodes, I will create a DFS of them through my this function. This is also a basic DFS function because I just want to find some possible DFS. Okay, now I push all of this into this vector. I reverse it. I push back the source because I have to come back to the source. And then I simply push all of the values of this into my main answer. And then I go to my next node of the path and continue this same process. Okay, one last example I'll show. Let's say we have 1, let's say we have 2, let's say we have 3. 1 is the start, 3 is the end, and there are many buffer nodes over here. Okay, so we start at 1. 1 is in my answer. I don't have any buffer nodes at 1, so 1 is my answer. I come to 2. I have many extra nodes. Let's take the DFS of all nodes starting from 2 except 3. So it will be just 5, 4 and 6. 5, 4 and 6. Now reverse this. 6, 4, 5. 6, 4, 5. Okay. So after this we apply 2. Okay. And then we come back to 3 and here's my 3. Okay. So we're starting from 1. Now we go to 6, so we'll come to 2. Next is 4, so we'll come here. Next is 5, so we have come back to 2 and all my buffer nodes are complete. Now I just go from 2 to 3 and that's my answer. Okay, so thank you guys for watching. Make sure to like, share and subscribe to our channel.